Okay, let's look at this question from November 2016. In the circuit diagram below, the reading on voltmeter 1 is 12 volts and the reading on ammeter 1 is 2 amps. Calculate the total resistance of the circuit. Okay, so in this circuit we have here one series resistor and two parallel resistors. So in order to calculate the total resistance, what we have to do is we have to get this R series. Okay, so the R total will be the R series plus the R parallel. Okay, so let's work this out here. So my R total, what is my R series? There's a 4 ohm in series. What is my R parallel? Now remember, to calculate the parallel resistance, you say 1 over R total is 1 over R1 plus 1 over R2. But my favorite way is to use this, where you multiply the two resistances and then divide by the sum. So I'm going to do that. So on top, my resistances here are 6 ohms and 3 ohms. So I'm going to go 6 times 3 over, whoops, eventually I'll get a divide sign there, over 6 plus 3. So if you go 6 times 3 is 18, 6 plus 3 is 9. So my R total is going to be 4 in series, okay, plus, like I said, 6 times 3 is 18, divided by 6 plus 3 is 9, 18 divided by 9 is 2. So my total resistance equals 6 ohms. No unit, no mark. Okay. Now it says to you, what is the reading on voltmeter 2? So if we have a look here, voltmeter 2 is this one over here. So now what you can do here is you can use V equals IR, okay? Even though you're not supposed to know it, you must know V equals IR because it's not on the formula sheet. So let's write down V equals IR, normally 1 mark for the formula. My volts are going to be, what is my current? Remember, current is the same everywhere in a series circuit. My current is 2 amps. And then my resistance is 4 ohms. So my voltage is going to be 8 volts. Okay. So that's my voltage on voltmeter 2. Because remember, the circuit is going to divide the voltage up between these two resistances. What is the reading on ammeter 2? Okay, now there's a couple of ways you can calculate this, okay? If you consider this circuit as a whole, if you consider this as one resistor, then the voltage over here is going to, plus the voltage over here is going to give you 12 volts. Remember, series resistors are voltage dividers, potential dividers. So here is 12 volts, 8 volts of it's going through here, leaving you 4 volts for over here. And then you can use V equals IR with the 4 volts over here. Or the other way is to say that this is going to be in a ratio, okay? This is the current here is going to be divided here because we're looking for a current now. And so these two resistors are current dividers. And so we can say that they're going to divide them in the inverse ratio. Remember, parallel resistors, the biggest current goes through the smallest resistor. I always say to you, it's like kids doing their homework. If you give them options, they'll all do the easy option, except for a few kids who'll do the hard option. So this current's going to come up here, and it's going to split between these two resistors in an inverse relationship to their ratio. So if you have a look here, the ratio is 6:3, okay, of the resistance. So it's a ratio of 6:3. And most of the current is going to go through here, so less current is going to go through here. But they said to you, what do they want? Ammeter 2. So here's ammeter 2, so we want to know what's going to go through the 6 ohm resistor. So what we have to do is we have to flip the relationship. It's going to be the smaller number, 3, okay, over the total of the ratio. The total of the ratio is 6 plus 3 is 9. Okay, so it's going to be 3 over 9 times, let's That's not times. That's not times either. It's going to be the ratio over the current in the circuit, so it's going to be 3 over 9 times 2. And if you work that on your calculator, you're going to get to 2/3, which is 0.67 amps. Okay, are you following what I did there? If you're not following what I did there, I'm about to explain again. Okay, so your option here is to say, I've got this much current in my circuit, 2 amps. When it arrives at this point, the current's going to split up. The current splits up so that most of the current goes through the smaller resistor. It's got an inverse relationship. So what I can do is I can find the total resistance of these two is 9. Okay, well, it's not the total resistance of these two. It's the total of the ratio of these two, because these two are 6 is to 3 in the ratio. The total of the ratio is 9. But because it's an inverse relationship, I'm going to only find the smaller fraction is going to go through here. So it's 3 over 9 times 2, which gives you 0.67 amps. Okay. Now it says to you, find the amount of charge that flows through ammeter A1 in 120 seconds. We're going to use this formula Q equals I delta T. I'm not very good at writing in delta, so I'm just going to write in the formula the shorthand way, Q equals I T. Please do not do this. Please copy the formula exactly. But Q is my charge, and it's going to be equal to the current, which is 2 amps, times the time. Handily, it's in seconds. Remember, you have to put everything in the SI unit here. So this is going to be 240. No unit, no mark. Charge is measured in coulombs. So this is going to be 240 coulombs of charge passed through there in 120 seconds. How will the reading on ammeter A1 be affected if the 6 ohm resistor is removed from the circuit? Right, only increases, decreases, or remains the same. Okay, so first of all, find the 6 ohm resistor. The 6 ohm resistor is in parallel. If we remove a parallel resistor, the resistance is going to increase. If the resistance increases, the current is going to decrease. Okay, so the current is going to decrease. Now it says explain the answer to question 2.5 without any calculations. So what you have to say is this whole long explanation that I've just given for why we got decrease. Okay, so if the 6 ohm resistor is removed, the total resistance of the circuit will increase. Okay, the voltage supplied by the battery cannot change. Okay, because if the voltage could change, we might have a problem. So the voltage supplied by the battery cannot change. Then we say current is inversely proportional to resistance, because we know this, because we remember it. So when the resistance increases, the current decreases. And there you have it. There is the answer to the question.